Welcome back. We've got a lot to do on our lending-based stablecoin. We have to allow repayments, and we have to allow multiple users to take out a position. To do so, we're going to learn about Vyper HashMaps. Let's start by fixing up something that's hopefully been bothering you as much as it's been bothering me. In the last unit, we created a structure for a loan, everything that you need to describe a loan. But the problem was we didn't have any way of associating a loan with a user, so we just associated one loan per contract, which means different users would have to redeploy a contract from scratch, which wouldn't really work. It's not ideal. The way that this is handled within smart contract universe is a mapping. You have a way and means of mapping individual indices to a value. So this user has this loan. This other user has this separate loan. In Vyper, this is declared as a hash map. And there's a reason it's called a hash map. And when you understand the reason it's called a hash map, you'll also understand a bit of how it works under the hood and how this is very different from when you're working with multidimensional objects in Python. You might look at the syntax and think immediately, this looks similar to a Python dictionary. In Python, a dictionary allows you to map an index to a value. And similarly, like we see here in Vyper, there's a lot in common. You can have this be multidimensional, you can have it mapping to somewhat disparate types. But there's a big difference. In Python, a dictionary is bounded. That is, if you create a dictionary with 5 elements, it has a length of 5. In Vyper, the hash tables are initialized in the EVM in such a way that every possible key exists. It's mapped to a default value, usually something like 0. Because of this means every hash map is technically infinite in length. So you can't iterate through every single item in a hash map. You have to be careful about this with your design, because some people want to be able to iterate over every user that has a balance. You have to come up with a separate object to do this. HashMap can only look up a given value and see what exists there, or if nothing exists there, return a default value. With this in mind, let's go ahead and upgrade this now, so that instead of an open loan pointing to a single loan, let's create a mapping, an address to a loan. We'll change the nomenclature from open loan to open loans. And we'll go ahead and instantiate this as a hash map of an address pointing to a loan. You'll notice, no problem, we can create a hash map pointing to a structure. That is totally fine. Next up, let's see where open loan exists elsewhere, and let's fix this. So repay amount is a key one. This is the internal function that we created last time that says, how much do we repay? Well, now we have to say, how much does this user repay? And when we get there, we'll use the square bracket, similar to Python dictionaries, to look up the address, the specific user. Now, this, of course, is going to affect the repay amount function we also created. So we created this just blanket because there was no concept of a single user. Here we have to now pass a param address to look up. But we're just passing this along pretty easy. Let's see where else open loan exists. Yeah, here we're also creating an open loan, and in this case we're trying to establish the parameters. Because we're no longer writing a single loan to this, we're trying to write a loan at a specific address. We'll do this here at message.sender. We'll now receive the loan object. So everything looks pretty good. I don't see any other instances of open loan singular that we missed. So we have converted our open loan struct to an open loan struct address pointing to HashMap. There's one more thing we have to do to pass our tests, and that's that we need to build out this repay function. Because what good is a loan if you can't repay it? So right now we're not going to give them any capability of repaying in special ways. It's just going to be a hard repay loan in full. And we'll note that this could revert for a few reasons. If the user lacks approval, or the balance to repay in full. So in order to build this out, let's build out, first start these checks that we need Then we'll try to transfer tokens. Rather, we'll say stablecoin. Then we will clear out the loan. And finally, we will return the user's collateral. Seems sensible. To make my life easy, I'm going to create a variable called user that is the message sender. Then I will assert that the stablecoin balance of the user is sufficient to cover the repay amount for that address. We also said that we would check that the user has the approvals. Well, instead of just doing an explicit check, we'll just try and transfer the stablecoin, and if it fails, we will know why. We're gonna go from the address and the user to person to clear out the loans. We will do open loans at that particular address. And this is going to be overriding this with a empty loan object. And finally, we need to return the user's collateral. Well, first up, we need to store the user's collateral to return before we call this function to clear out the loan. So let's look at that open loans object at the address and get the deposit amount. And finally, after it's been zeroed out and everything has worked properly, we will transfer to the user the quantity of tokens. Keep typing address. This is user. And we'll try and run this now and see how many typos we made. We usually get at least a couple. Indeed, I'm still hung up on open loan, but we're no longer in the open loan world. We're now using these mappings to associate multiple users with multiple different singular loans at this point. So while the tests are running, just one quick note. We're making this pretty simple, where the loan can't be altered once it's been created, and you have to repay it in order to do anything new with it. In this case, we have a pretty simplistic address to loan, but you might want to change this for your purposes. You might want to allow a user to take out multiple loans. You might want to allow a user to add or reduce collateral in part and adjust their loan in based on the present spot price. There's a lot that you can really do. Of course, this is just scratching the surface, but now that you understand hash maps, you really understand the key to how you can connect and build out these kind of larger connections and mappings of value. Good luck out there. Drop any questions in the comments if you have them. We'll be happy to take a look.